His heart stopped while the machine was still running. The electroencephalogram had been placed on his head to monitor seizures, routine, unremarkable. And then, without warning, at Tartu University Hospital in Estonia in 2022, an 87-year-old man died mid-recording. What the data showed next has not left the scientific community since. In the 30 seconds surrounding the moment of death, his brain did not go quiet. It erupted. Gamma waves, the fastest, most complex oscillations the human brain produces, the same patterns that fire during vivid dreaming, deep meditation, and the retrieval of profound memories, surged through his cortex in organized, coherent waves. The dying brain was not shutting down. It was doing something. Something that looked, to the researchers who published the findings, remarkably like a replay of a life. For as long as human beings have been conscious of their own mortality, that question has sat at the center of everything, and science has never been able to answer it. Then the data started arriving. This video will trace that data wherever it leads, through the neuroscience of the dying brain, the chemistry your body may release at the final moment, the patients who came back from clinical death describing things they could not possibly have seen, and the oldest maps of the afterlife ever drawn, which match the modern findings with a precision that demands explanation. If these are the kinds of questions that keep you up at night, consider subscribing. There is a great deal more where this is going. Something is happening at the threshold of death. We are only now beginning to understand what. There is a man whose name we will never know. He was 87 years old, and he was being treated at a hospital in Tartu, Estonia, for seizures that had developed following a brain injury. The doctors had placed electrodes across his scalp, a standard procedure, nothing unusual about it, to monitor the electrical activity of his brain. They were tracking epilepsy. They were not studying death. And then his heart stopped. What happened next was an accident of science. The machine was still recording. And in that unplanned window, in those final moments that no researcher had anticipated capturing, the data produced something that the field of neuroscience had never seen before. The brain did not go quiet. It surged. To understand why that matters, you need to understand what the machine was measuring. An electroencephalogram, the device attached to this man's head, detects the electrical oscillations produced by the brain's neurons as they fire and communicate. These oscillations come in different frequencies, and each frequency is associated with different mental states. Slow delta waves appear during deep, dreamless sleep. Theta waves rise during drowsiness and light sleep. Alpha waves characterize a relaxed, wakeful mind. Beta waves accompany active thinking and alertness. And then there are gamma waves. Gamma waves are the fastest oscillations the brain produces, the highest frequency rhythms measurable by standard equipment. They are associated with the most demanding cognitive operations: conscious perception, the active retrieval of memory, deep meditative states, and vivid dreaming. When you are intensely focused, when you recognize something familiar, when you are assembling fragments of experience into a coherent whole, gamma waves are there. They are, in a very real sense, the electrical signature of the brain doing its most complex work. In the 30 seconds surrounding this man's cardiac arrest, gamma wave activity did not diminish. It exploded. Organized, coherent surges of the brain's most complex oscillatory pattern erupted through his cortex, not randomly scattered, but structured. Communicating. The researchers who published the findings described what appeared to be a surge of neural activity, concentrated in regions associated with conscious experience and memory processing. Think about what the data is saying. A brain deprived of oxygen, no blood circulating, every physiological system failing. And yet this brain was producing more organized, complex electrical activity in those final seconds than it had been producing in the minutes before the heart gave out. That is the paradox, and it has not gone away. The recording in Tartu was, by any scientific standard, a single data point. One patient, one machine left running by chance, one unrepeatable window The scientific community could note it, discuss it, and file it under the category of extraordinary but inconclusive. What it could not do was ignore it, because the same question had already been circling the edges of neuroscience for years, raised by an entirely different line of research happening in laboratories far from Estonia. In 2013, a team at the University of Michigan made a discovery that should have been impossible by the assumptions then governing the field. They induced cardiac arrest in rats while monitoring their brain activity continuously, and what they recorded upended a foundational assumption about what death looks like from the inside. In the seconds following cardiac arrest, the rats' brains did not enter a state of electrical collapse. Instead, they showed a dramatic and coordinated surge of activity, cross-hemispheric, high-frequency, organized, of precisely the kind associated with conscious processing in the living brain. The lead researcher on that study, Jimo Borjigin, spent the following decade pursuing the human equivalent of that finding. The question was deceptively simple. Does the same thing happen in the dying human brain? And if it does, what could it possibly mean? The answer came in 2023, and it came from the most ethically careful circumstances imaginable. A group of comatose patients, individuals whose families had made the devastating decision to remove life support, were monitored with continuous brain activity recording before, during, and after the withdrawal of ventilation. This was not an experiment conducted on unwitting subjects. It was a study built around a tragedy that was already unfolding, designed to extract knowledge from the most difficult of human moments. 2 of the 4 patients monitored showed what the research team described as a massive surge of gamma wave activity in the minutes following the removal of ventilation. The activity was not diffuse or random. It was concentrated in a specific area of the brain, the junction where the temporal, parietal, and occipital lobes converge at the back of the skull. That region is worth pausing on because it is not an arbitrary location. The temporal, parietal, occipital junction is one of the most studied areas in the neuroscience of consciousness. It is the region responsible for integrating sensory information, taking the raw inputs arriving from your eyes, your ears, your sense of your own body in space, and weaving them into a unified experience of being somewhere, being someone, perceiving a coherent world. It is also the region that activates during out-of-body experiences. It lights up during vivid dreaming. It is, in a meaningful sense, where the brain builds the felt sense of being present. And it was this region, of all possible regions in the dying brain, that erupted in those final minutes. The gamma connectivity observed did not stay localized. It spread across hemispheres, linking the activity at the back of the brain to the prefrontal cortex at the front, the region responsible for higher-order thinking, for self-awareness, for the kind of processing associated with meaning rather than mere sensation. The back of the brain was talking to the front. Perception was communicating with understanding. George Mashua, who helped lead the analysis of these findings, used a phrase that captures the problem precisely. He called it a neuroscientific paradox. How does a brain that is shutting down, that has lost its blood supply, that is being progressively starved of the oxygen it needs to function, produce the most complex and organized electrical activity of its recent existence? The standard model of death, the one that has governed clinical medicine and popular understanding alike, is a model of progressive subtraction. The heart stops. The brain loses its fuel. One by one, the systems go dark. The process is imagined as something like the fading of a screen, a slow dimming toward nothing. That model is wrong, or at least, it is radically incomplete. What the data from both the rat studies and the human recordings suggests is that death is not a passive event. It is active. The brain does not simply receive the news that oxygen has stopped arriving and begin an orderly shutdown. Something else happens first. Something that looks, from the outside, like a last tremendous effort, a final mobilization of the brain's most sophisticated resources at the precise moment when the resources to sustain them are disappearing. The question this raises is not a small one. If the dying brain is this active, then it is doing something. The activity is too structured, too coherent, too concentrated, in precisely the regions associated with consciousness to be dismissed as noise. The brain in those final moments appears to be processing. And if it is processing, then the person inside that brain may be experiencing something. What that something is, nobody yet knows with certainty. But the shape of the evidence suggests a direction. Sam Parnia, who runs one of the most rigorous programs of death research in the world from NYU Langone Health, has spent years pushing at the boundary between what medicine declares death to be and what the biology actually shows. His argument, supported by accumulating data, is that the moment of clinical death is not the moment of experiential death, that the window during which meaningful brain activity can occur, during which a person may still be in some sense present, extends far beyond what the flat line on a cardiac monitor implies. He has suggested that organized brain activity may persist for up to an hour after the heart stops, perhaps longer. Consider what that means in practice. The moment a doctor looks at a clock and records the time of death, the brain of the person just declared gone may still be generating the most complex electrical activity it has produced in recent memory. The announcement and the reality may not coincide. This is not a comfortable idea. It is not meant to be. It is what the data suggests. And the data does not stop there. Because the question of what the dying brain is doing is inseparable from a deeper question. The question of what the dying brain might be experiencing. And for that, we need to talk about the people who went to the edge of death and came back, and what they reported seeing when they got there. The AWARE study, which stands for Awareness During Resuscitation, was designed by Parnia and his colleagues to do something that had never been done with scientific rigor, to take the accounts of cardiac arrest survivors seriously. Not as anecdote, not as curiosity, but as data, to collect those accounts systematically across multiple hospitals with controlled conditions and ask what they actually tell us. The study ran for 4 years. It spanned 15 hospitals across the United Kingdom, the United States, and Austria. 2,060 patients suffered cardiac arrest during that period. Of those who survived and could be interviewed, 39% described some form of structured awareness during the period when their heart had stopped. Not vague impressions, not the confused fragments you might expect from a malfunctioning brain. Organized, sequential, meaningful experiences. Experiences that many of the survivors described as more real than ordinary waking life. One case stood apart from the others. A 57-year-old man suffered cardiac arrest in a United Kingdom hospital. His heart stopped for 3 minutes. Standard neuroscience holds that meaningful brain function ceases within 20 to 30 seconds of cardiac arrest, that the brain, deprived of oxygenated blood, simply cannot sustain the kind of processing required for coherent experience. This man's heart was stopped for 6 times that window. When he was resuscitated, he described what had been happening in the room during those 3 minutes. He described the actions of the medical staff, specific actions, in sequence. He described the sounds of the equipment. He described details that were later verified by the nurses and doctors who had been working on him. Details he could not have known. Details his brain, by every standard model of what cardiac arrest does to consciousness, should have been entirely incapable of perceiving. The medical team confirmed his account. Parnia's team did not claim to know what this meant. They reported it. The data showed what it showed, and what it showed was that a man with no measurable heartbeat, in a brain that should have been electrically silent, had somehow acquired accurate information about events occurring in the physical world around him. The second phase of the study, AWARE 2, expanded the scope and added a layer of real-time monitoring. 25 hospitals, 567 patients. 85 of those patients were monitored with continuous brain activity recording during the resuscitation attempt itself. The researchers were no longer just interviewing survivors. They were watching the brain in real time as clinicians fought to bring it back. Of the patients who survived and were interviewed, nearly 40% reported memories or perceptions consistent with consciousness during their cardiac arrest. 6 described structured, sequential experiences during verified periods of clinical death. And the brain activity data added something that no previous investigation had captured: organized electrical patterns, delta, theta, and alpha waves, the signatures of various states of conscious processing, detected up to 60 minutes after clinical death had been declared. 60 minutes, not seconds. Not a brief anomalous spike in a single recording. Sustained organized electrical activity across multiple patients for up to an hour after the moment medicine had called them gone. Pania described what he believed was happening. The dying brain, he proposed, undergoes a process of disinhibition. In ordinary life, the brain operates under a network of inhibitory controls, internal braking systems that regulate and constrain conscious experience, filtering the vast totality of stored memory and sensation down to what is immediately relevant. These systems require energy to function. As the brain loses its blood supply, those controls begin to fail. The filters come off. What emerges, Pania suggested, may be something like the full, unfiltered archive of a life, memories accessible not as sequential replay, but simultaneously, evaluated not merely as personal history, but as moral weight. The impact of your actions seen from the perspective of those who experience them. That is an extraordinary claim. It is also one of the most consistently reported features of near-death experience across every study that has ever documented it. And it is a description that, as this investigation will show, appears in traditions far older than neuroscience, described in strikingly similar terms by cultures that had no access to EEG data, no knowledge of gamma waves, and no way of knowing that the dying brain might produce exactly this. The pattern is there. It has been there for a very long time. We are only now building the instruments to see it. Raymond Moody was a philosophy student when he first heard the accounts. It was the mid-1960s, and a psychiatrist named George Ritchie had described to him, in careful detail, what had happened during the 9 minutes he was clinically dead from double pneumonia at the age of 20. Ritchie described leaving his body. He described moving through a tunnel toward an overwhelming light. He described a review of his entire life, not as a sequence of memories, but as a simultaneous, morally weighted re-experience of everything he had done and felt and caused others to feel. Moody was trained in skepticism. He was also paying attention. He began collecting similar accounts, quietly, methodically, over the following years, and when he published them in 1975 under the title Life After Life, the response was unlike anything the publishing world had seen from a book on this subject. It sold millions of copies. It generated controversy in equal measure, and it did something that no amount of controversy could undo. It established, for the first time in the modern era, that the experience of dying followed a recognizable pattern. The tunnel, the light, the encounter with others, the review of the life, the boundary that could not be crossed. These were not the idiosyncratic visions of disturbed minds. They were the consistent reports of ordinary people who had been, by every clinical measure, dead and had returned. The scientific establishment was not impressed. Anecdote is not data. Personal testimony, however vivid and however consistent, does not constitute evidence by the standards that science requires. What was needed was rigorous methodology. Large samples, controlled conditions, standardized measurement, and a willingness to follow the findings wherever they led without presupposition. Kenneth Ring provided the first real attempt. A psychologist at the University of Connecticut, he spent years conducting structured interviews with near-death experience survivors and analyzing the results statistically. His 1980 book, Life at Death, was the first systematic scientific investigation of the phenomenon, and it produced findings that have never been meaningfully refuted. The core structure Moody had described was real. Across Ring's sample, the same features appeared repeatedly, in the same sequence, regardless of the circumstances that had brought the person to the edge of death. Cardiac arrest, drowning, accidents, surgical complications. The route to the threshold varied enormously. What was reported on the other side of it did not. And here is the detail that Ring considered most significant. The content of the near-death experience did not correlate with religious background. Christians and atheists, Hindus and agnostics, people who had spent their lives in church and people who had never set foot in one. They reported the same structure. The tunnel was not a Christian tunnel. The light was not a specifically Buddhist light. Whatever was generating these experiences, it was not cultural expectation. That finding has held up across every serious study conducted since. What has become more nuanced over time is the question of what happens within that consistent structure. Because while the architecture is universal, the specific content is not, and the differences are revealing. Western patients, particularly those raised in Christian traditions, frequently report encountering figures they interpret as Jesus, or angels, or deceased relatives dressed in robes of light. Hindu patients in India have reported being told by messengers that a mistake has been made, that they are the wrong person, and being sent back, a detail that appears in the Indian near-death literature with a consistency that researchers have found striking. Japanese accounts place a distinctive emphasis on beautiful rivers and pastoral landscapes populated by deceased family members who arrive, in some reports, by boat. The beings encountered differ. The landscapes encountered differ. The emotional register, overwhelming peace, unconditional love, a sense of returning to something rather than encountering something new, does not differ at all. Think about what that pattern is telling you. Strip away the culturally specific imagery, and what remains is a structural experience that appears to be generated not by belief, not by expectation, not by what the person feared or hoped death might look like, but by something else entirely, something that produces the same architecture in every brain, in every culture, on every continent, regardless of what that brain believed was waiting on the other side. Whether that something is neurological or metaphysical is a question this investigation will return to. For now, hold the pattern. It matters. One of the most consistently reported features of that pattern, and one that the neuroscience discussed in the previous section begins to illuminate, is the panoramic life review. Survivors do not describe this as watching a film of their life. They describe something far stranger and far more demanding. The review is simultaneous rather than sequential, the entire life present at once, not played out in order. It is immersive rather than observational. You are not watching. You are inside every moment you are reliving. And it is evaluated not from your own perspective, but from the perspective of every person you ever affected. The kindness you showed a stranger 30 years ago, the cruelty you inflicted on someone who trusted you, the small acts of honesty, and the larger acts of cowardice. Every one of these is re-experienced, not as you experienced it at the time, but as the other person experienced it. You feel what they felt. You understand, with a completeness that ordinary life never permits, the weight of what your actions actually meant to another human being. Multiple survivors, across multiple studies, have described this as the most morally significant experience of their lives. Not frightening, not punitive, but inescapably honest. That description should ring a bell. It will ring several before this video is done. The children complicate the picture in a way that skeptics find difficult to explain away. Near-death experiences in very young children, children too young to have absorbed the cultural frameworks that adults carry into every experience, follow the same structural pattern as those of adults. The tunnel appears, the light appears, the sense of peace appears, the encounter with others appears. Children who have not yet been told what death is supposed to look like are reporting the same architecture that a retired professor in Ohio and a farmer in rural India are reporting. Cultural conditioning cannot account for that. The child has not been conditioned. The child has barely been. Bruce Greyson spent 50 years at the University of Virginia studying near-death experiences with the methodological rigor the subject demands, and his conclusion, published in his comprehensive synthesis of the field, is that whatever is generating these experiences, it is not adequately explained by any current model of brain function, not by oxygen deprivation, not by the release of endorphins, not by the misfiring of a dying visual cortex. Those explanations account for parts of what survivors report. They do not account for the verified perceptions. They do not account for the children. They do not account for the cross-cultural structural consistency that appears in populations with no shared religious or philosophical framework. And they do not account for what Christopher Kerr discovered in the hospice. Kerr is a physician at Hospice Buffalo in New York, and the question he pursued was a different one. Not near-death experience, not the accounts of people who had been clinically dead and returned, but the experiences of people who were dying more slowly, over days and weeks, and what they reported seeing in the time before the end. His team conducted a prospective longitudinal study of dying hospice patients, a study that ran for years, collecting accounts in real time rather than reconstructing them retrospectively. What the patients described, with a frequency and consistency that stunned even the researchers conducting the study, were visits. Deceased relatives appearing at the bedside, a parent who had been dead for 20 years, sitting in the chair by the window, a childhood friend, gone for decades, standing at the foot of the bed and waiting. These were not described as dreams. They were not described as hallucinations. The patients were awake, oriented, and clear when they reported them. And the visits were experienced almost universally as deeply comforting, as a form of accompaniment, a presence arriving to ease the transition. These are called deathbed visions, and they are distinct from near-death experiences in important ways. The person experiencing them has not flatlined. There is no cardiac arrest, no resuscitation, no clinical death to account for what is being seen. The brain is alive and functional, and yet it is perceiving, or appearing to perceive, figures that cannot be there by any materialist account. Kerr found that patients who experienced deathbed visions reported lower levels of end-of-life distress. The fear of dying, which is one of the most documented and universal features of the human confrontation with mortality, appeared to be diminished, sometimes dramatically, by these encounters. Whatever was being experienced, it was not frightening. It was, repeatedly, described as a form of welcome. The relationship between near-death experience and deathbed vision is not fully understood. They may be the same phenomenon arriving through different doors. They may be distinct processes that share a common origin. What they share, undeniably, is the structural feature of encounter, the sense that the approach to death is not a solitary passage, but an accompanied one, that something or someone is on the other side of the threshold, waiting. That feature appears in the world's oldest descriptions of dying. It appears in the clinical data collected by researchers who approach the subject with no intention of finding anything of the kind. And it appears in the accounts of people who had no knowledge of either. The pattern insists on itself. What is generating it remains the deepest question in this investigation. But before we can begin to answer that, we need to understand something that the neuroscience of the dying brain points toward, but cannot fully explain. A molecule that your brain may be manufacturing right now, whose concentrations appear to spike at the moment the heart stops, and whose effects, when administered to the living, produce an experience that maps onto the near-death reports with a precision that is very difficult to dismiss. The chemistry of the threshold is stranger than almost anyone anticipated, and it begins with a compound that indigenous cultures in the Amazon basin have been working with for centuries, that a clinical psychiatrist in New Mexico spent 5 years studying under federal approval, and that a research team at the University of Michigan confirmed in 2019 is being produced inside the cells of your own brain right now. In 1990, a psychiatrist named Rick Strassman received something that no researcher in the United States had been granted in more than 20 years. Federal approval to administer a powerful psychedelic compound to human volunteers in a controlled clinical setting. The compound was dimethyltryptamine. The study ran for 5 years at the University of New Mexico. 60 volunteers received intravenous doses under careful supervision, and what they reported in the minutes that followed, the experience lasts roughly 15 to 20 minutes when administered this way, bore almost no resemblance to what most people imagine when they hear the word psychedelic. There was no distortion of the ordinary world. There was no altered version of the room, no warped faces, no familiar things made strange. Instead, The volunteers described something more like a complete departure from the ordinary world altogether. The sense of self dissolved. The body ceased to feel like a body. And then, with a speed and totality that many described as more shocking than anything they had ever experienced, they were somewhere else entirely. Tunnels of light at impossible speed, landscapes of extraordinary complexity and beauty, and beings, entities, presences of overwhelming intelligence and apparent reality that many volunteers described as feeling more real than anything they had encountered in waking life. Some described being shown their lives. Some described being told things. Some described a sense of returning to a place they recognized, as if ordinary life had been the departure, and this was the homecoming. When the compound wore off, many of the volunteers wept, not from fear, from grief at having to come back. Strassman published his findings in 2000. He called the book DMT, the spirit molecule. In it, he proposed that the pineal gland, a small structure deep in the center of the brain, roughly the size of a grain of rice, might produce and release dimethyltryptamine at 3 critical moments: at birth, during dreaming, and at the moment of death. He framed it as a biological mechanism for spiritual experience, a chemical bridge between the physical brain and whatever might lie beyond it. The scientific community was unconvinced. The pineal gland's primary known function is producing melatonin, a hormone that regulates the sleep cycle. The idea that this tiny structure could generate a psychoactive surge at the moment of death seemed, to most researchers, to be an elegant speculation built on almost no direct evidence. The hypothesis had a poetry to it. It did not yet have data. Then the data arrived. In 2019, a team led by John Dean at the University of Michigan published a study in Scientific Reports that transformed the status of this question entirely. What they found was not a confirmation of Strassman's pineal gland hypothesis. It was something more significant. They were looking for the enzyme INMT, indolethylamine N-methyltransferase, the key biological machinery required to synthesize dimethyltryptamine in living tissue. And they found it. They found it expressed in the neurons of the mammalian neocortex. They found it in the choroid plexus, the structure that produces cerebrospinal fluid. They found it co-expressed in the same brain cells, alongside a second enzyme called AADC, which is also required for the synthesis pathway. Both enzymes, in the same neurons, in the cortex. This was not the pineal gland. This was the brain itself, the cerebral cortex, the seat of higher cognition, manufacturing the biological preconditions for dimethyltryptamine synthesis across a vast territory of neural tissue. They then measured actual concentrations of the compound in the brains of living rats using a technique called microdialysis, which samples the fluid surrounding neurons in real time. The concentrations they found were not trace amounts. They were comparable to serotonin and dopamine, two of the most fundamental neurotransmitters in the brain, molecules whose role in regulating mood, cognition, and consciousness is beyond scientific dispute. Dimethyltryptamine was not a curiosity found in trace quantities in an obscure gland. It was present throughout the brain at neurologically meaningful levels, and then they induced cardiac arrest. When the rat's heart stopped, dimethyltryptamine concentrations in the visual cortex spiked dramatically. The dying brain was not passively losing its chemistry. It was actively producing more of this specific compound at the precise moment that blood stopped flowing. The surge was real, it was measurable, and it happened without the pineal gland, because some of the rats in the study had already had their pineal glands surgically removed. The spike occurred regardless. The cortex was the source. The dying cortex, releasing a surge of one of the most powerful psychoactive compounds known to science, at the moment of death. A year before that study was published, a team at Imperial College London, led by Christopher Timmerman, had conducted a different kind of experiment. They administered intravenous dimethyltryptamine to healthy volunteers, a replication and expansion of Strassman's earlier work. But this time, they used something Strassman had not had available, a standardized near-death experience scale, the same measurement tool used by researchers like Grayson to evaluate and categorize the accounts of cardiac arrest survivors. The overlap was not approximate, it was structural. Ego dissolution, tunnels of light, encounters with presences or entities, a transcendent sense of crossing a threshold, overwhelming feelings of peace and unconditional acceptance, the sense that the experience was more real than waking life, a life review, a boundary. Point by point, the dimethyltryptamine experience mapped onto the near-death experience, not in the way that two similar things resemble each other, in the way that two descriptions of the same room resemble each other. This is the evidence, and it is genuinely remarkable, but it requires honest handling. David Nichols, a pharmacologist whose work on psychedelic compounds is among the most rigorous in the field, published a careful critique of the dimethyltryptamine death hypothesis in 2018. His objection was specific and serious. The pineal gland weighs less than 0.2 of a gram and produces roughly 30 micrograms of melatonin per day. To generate a psychoactive dose of dimethyltryptamine, the brain would need to produce something in the region of 25 milligrams, nearly 1,000 times the pineal gland's daily melatonin output. And dimethyltryptamine is broken down rapidly by monoamine oxidase enzymes that are present throughout the brain. Even if a surge occurred, Nichols argued, it would be metabolized almost immediately. Whether enough of the compound could accumulate in the right regions, at the right concentrations, within the right time frame to produce a full psychedelic experience at the moment of human death remains genuinely unknown. The rat data is real. The human extrapolation is not yet proven. What is confirmed? The brain makes this compound. It makes it at significant concentrations. Its levels rise during cardiac arrest. And when the compound is given to the living, it produces experiences that are structurally identical to what the dying report. What is not confirmed? Whether the human brain produces a psychoactive surge at death. That gap is honest, and this investigation will not paper over it. There is one further thread worth pulling before we leave the chemistry of the threshold. A review published in 2024 examined dimethyltryptamine's interaction with a class of proteins called sigma-1 receptors, which are found throughout the brain and are involved in neuroprotection, neuroplasticity, and cell survival during periods of extreme stress. What the review found was intriguing. Dimethyltryptamine appears to activate these receptors under conditions of hypoxia, oxygen deprivation, potentially shielding neurons from the damage that oxygen loss would otherwise cause. The compound may not just be generating an experience, it may be protecting the brain while generating it. A chemical last resort, the brain flooding its own cortex with a substance that simultaneously guards against damage and throws the doors of perception as wide as they will go. If that picture is accurate, and it is, at present, a picture with several pieces still missing, then what we call a near-death experience may not be a malfunction. It may be a feature. The brain doing precisely what it was built to do under precisely the conditions it was built to face. That possibility sits differently depending on which question you bring to it. For the neuroscientist, it raises the question of mechanism. How, precisely, does this work? And what can it tell us about the ordinary relationship between brain chemistry and conscious experience? For the philosopher, it raises a deeper question. If the brain produces a transcendent experience at the moment of death by design, does that tell us something about what transcendence is, or only about what the brain does? We will return to that question. First, we need to confront something that the neuroscience of dying cannot comfortably explain at all. Something that has been documented in hospital wards and hospices around the world, witnessed by clinicians who had no theoretical framework to accommodate it, and that sits like a splinter in the materialist model of mind. A woman in her 90s had been living with Alzheimer's disease for 9 years. She had not recognized her son in years. She could no longer tell you her own name with any reliability. She could not form a complete sentence. The neural architecture of herself had been, by every measurable standard, devastated. The hippocampus that stored her memories worn away. The cortical networks that held her personality riddled with the plaques and tangles that Alzheimer's deposits across a brain over decades. 24 hours before she died, she woke up. She knew her son's name. She knew her own. She knew the name of the facility she was in and could tell you what year it was. She held a conversation, a real conversation, not the fragmented, looping utterances of advanced dementia, but a coherent exchange between two people who recognized each other. She said things that needed to be said. And then the next morning, she was gone. This is called terminal lucidity, and it is one of the most scientifically troubling phenomena in the entire landscape of death research. Not because it is rare, but because of what it implies. Alexander Bathiani and Bruce Grayson documented what the medical literature already contained in scattered case reports and confirmed it systematically. This happens. It is not a myth, not a misremembered account softened by grief. Their research established that in only 6% of documented paradoxical lucidity cases does the person survive more than a week. This is a phenomenon that appears at the edge of death and almost nowhere else. Surveys of palliative care workers have found that nearly 3/4 report witnessing at least one episode in their careers. A prospective study, led by a team at the University of Pennsylvania, interviewed 30 family caregivers of severe dementia patients and found that 25 of the 30 described at least one lucid episode in the period before death. 34 distinct events across 30 families. Seconds of recognition. Minutes of conversation. In one account, a man who had been entirely nonverbal for months asked for a cigarette and a beer, sang songs with his family, laughed, and talked for 45 minutes. The next morning, he was dead. Sam Parnia's team at NYU Langone, working with NIH funding from the National Institute on Aging, has now launched the first large-scale prospective study of this phenomenon, enrolling over 1,500 patients with moderate to severe dementia, equipping their care environments with continuous EEG monitoring, and attempting to capture the brain activity signatures of lucid episodes in real time. The goal is to identify the electrocortical fingerprint of terminal lucidity. If it can be found, it may point toward mechanisms that could eventually be used therapeutically, ways of giving people with severe dementia access to themselves, even briefly, before the end. But the therapeutic implications, significant as they are not what makes terminal lucidity so philosophically dangerous to the standard model. Here is the problem. Neuroscience's account of consciousness rests on a foundational assumption that your memories, your personality, your sense of self are stored in the physical structure of your brain, encoded in the synaptic connections between your neurons, maintained by the integrity of the neural networks that were built over a lifetime of experience. When those networks are destroyed, the functions they supported are destroyed with them, permanently, irreversibly. The storage medium is gone. The information is gone. Alzheimer's disease destroys those networks systematically. The hippocampus, the brain's primary memory-forming structure, is typically among the first regions to be devastated. The cortex follows. Brain scans of patients with end-stage Alzheimer's show not just damaged tissue, but absent tissue. The brain has physically shrunk. The structures that held a lifetime of memory are, in many cases, no longer there. And yet, terminal lucidity happens. People whose brains have been ravaged by decades of neurodegeneration suddenly access memories that should be gone. They demonstrate cognitive functions that the physical substrate available to them should be entirely incapable of supporting. They become, briefly and impossibly, themselves. There are hypotheses that attempt to contain this within a materialist framework. One involves what researchers call silent synapses, dormant neural connections that exist in far greater numbers in the adult cortex than was previously understood, connections that are not actively used but that remain structurally intact. Under specific conditions, these dormant connections might temporarily route around the destroyed pathways of Alzheimer's disease, restoring network function through detours that ordinarily remain untraveled. The dying process itself, with its wave of disinhibition, might be precisely the condition that temporarily opens those routes. Another possibility connects to findings published in 2024 in the field of molecular neurodegeneration. Researchers examining the toxic amyloid beta oligomers that accumulate in Alzheimer's disease found that these deposits do not build up steadily and uniformly. They fluctuate. They clear from certain regions temporarily, creating windows in which specific areas of the cortex might function more normally. Not because the underlying damage has reversed, but because the active interference has briefly lifted. These are not proven explanations. They are directions in which the evidence points. The honest answer is that terminal lucidity is not fully understood, and that its existence exerts genuine pressure on any account of mind that treats the brain as the sole and sufficient container of consciousness. If the storage medium is gone and the information persists, even briefly, even only at the edge of death, then something about the model is incomplete. What that something is will occupy the rest of this investigation. In the spring of 2016, a group of people with terminal cancer sat in a room at Johns Hopkins University and were given a single dose of psilocybin. They knew they were dying. Most of them had been living with that knowledge for months, and the fear that accompanied it, not just the abstract awareness of mortality that all of us carry, but the concrete daily weight of a prognosis, had become, for many of them, as debilitating as the illness itself. End-of-life anxiety is not a peripheral concern. It shapes the final chapter of a life with a force that medicine has historically been poorly equipped to address. What happened after the psilocybin sessions was documented carefully. Roland Griffiths and his colleagues at Johns Hopkins measured the outcomes using standardized psychological assessments, tracking depression, anxiety, and what researchers in this field call existential distress, the particular terror of confronting your own dissolution. The results were striking enough that the study was published in the Journal of Psychopharmacology and has since become one of the most cited papers in the emerging field of psychedelic medicine. The fear of dying decreased, substantially, sustainably, not as a temporary chemical suppression that faded when the drug left the system, but as a lasting shift in the participants' relationship to their own death, a shift that persisted at the 6-week follow-up, and in many cases well beyond. Participants described the experience as among the most meaningful of their entire lives. Several described it as the most meaningful, and they described something specific that accounted for the change. Not the erasure of the awareness that they were dying, but the dissolution during the experience of the self that was afraid. A parallel program at New York University, led by Anthony Bossis, produced findings that mirrored the Johns Hopkins results with a consistency that the researchers found remarkable. Across both programs, the report that recurred most frequently was not relief, not euphoria, not the absence of something. It was the presence of something, a sense of unity, of boundlessness, of belonging to something so vast that the individual self and its individual fate seemed, temporarily, beside the point. Patients returned from those sessions and described the experience of dying differently, not as falling into nothing, as returning to something. To understand why psilocybin produces this, you need to understand something about what it does to the brain, specifically, what it does to a network that neuroscientists call the default mode network. The default mode network is a set of interconnected brain regions that activates when you are not engaged with any particular external task. It is most active when you are thinking about yourself, ruminating, planning, constructing the ongoing narrative of who you are and what your life means. It is the neural substrate of the ego, the machinery that generates and maintains your sense of being a continuous, bounded individual moving through time. It is also, for many people in the final months of life, the machinery that generates the most relentless and the most painful thoughts they have ever experienced. Psilocybin suppresses default mode network activity dramatically. The self-referential processing that ordinarily dominates conscious experience is quieted. The boundaries that ordinarily define where you end and the world begins become, temporarily, permeable. And what many people report in that state, whether they are terminally ill patients in a clinical trial or healthy volunteers in a research study, is not the absence of consciousness, but an expansion of it. Not less experience, but more. As if the ordinary self, with its constant narration and its constant fear, was a narrowing rather than a container. Ketamine arrives at a related destination by a completely different route. Where psilocybin acts primarily on serotonin receptors, ketamine blocks NMDA receptors, a class of glutamate receptor involved in synaptic transmission and the integration of sensory information. At dissociative doses, it produces something that has been described in the clinical literature and by patients alike in terms that should by now be familiar. Separation from the body, movement through a dark space toward a source of light, encounters with presences, and an overwhelming sense of peace and acceptance. Carl Janssen, who studied this overlap systematically, proposed that the neurochemical state produced by NMDA receptor blockade, whether caused by ketamine or by the endogenous surge of compounds released during oxygen deprivation, may be the common substrate underlying both ketamine dissociation and the near-death experience. The brain, starved of oxygen, produces a chemical environment that resembles, in its receptor pharmacology, the environment produced by a dissociative anesthetic. The experiences those environments generate are, correspondingly, similar. This is a compelling hypothesis. It accounts for the tunnel. It accounts for the out-of-body state. It accounts for several of the most reliably reported features of cardiac arrest experience. It does not account for the verified perceptions, and it does not account for what happens with 5-MeO-DMT. 5-methoxy-N-dimethyltryptamine is the most potent naturally occurring psychedelic compound known to science. It is produced by several plant species and, more famously, by the parotoid glands of the Sonoran desert toad. It is structurally related to dimethyltryptamine, but pharmacologically distinct, and the experience it produces is, by nearly every account, categorically different from any other altered state, including the dimethyltryptamine experience itself. Where dimethyltryptamine tends to produce vivid, complex visionary content, the entities, the geometry, the landscapes, 5-MeO-DMT produces something closer to the annihilation of content altogether. The self dissolves not into a richer world, but into an undifferentiated ground of being. There is no visual content, because there is no observer to have visual content. There is only awareness, vast, formless, without boundary or object, and a sense that this awareness is not something the self is having, but something the self has always been, with the ordinary self as a temporary and somewhat illusory narrowing of it. The overlap with mystical experience across every tradition in human history is not incidental. The descriptions given by people who have taken 5-MeO-DMT in research settings, descriptions collected under the same rigorous conditions used to study psilocybin, match the descriptions given by contemplatives across Buddhism, Vedanta, Sufism, and the Christian mystical tradition with a specificity that suggests they may be describing the same state, arrived at by very different means. And that state, the dissolution of the self into an undifferentiated awareness that feels more fundamental than ordinary consciousness, is also what near-death experience survivors, across every culture and every era, most consistently describe at the deepest point of their encounter with death. Here is the thread that runs through all of it. Dimethyltryptamine, psilocybin, ketamine, 5-MeO-DMT. These are four chemically distinct compounds that act on different receptors through different mechanisms. They are not the same drug. They do not produce the same experience in any simple sense, and yet they converge, when administered at sufficient doses under the right conditions, on the same structural territory. The dissolution of the self, the sense of something larger, the conviction upon return that what was experienced was more real than the life one returned to. The dying brain, meanwhile, releases its own chemistry at the threshold. The gamma waves surge. The inhibitory filters come off. Dimethyltryptamine concentrations rise. And the people who return from the edge of clinical death describe, in their own words, from their own cultures, with their own imagery, the same fundamental territory that the compounds describe. What does that convergence mean? There are two ways to hold it. The first is neurological. that all of these experiences, the psychedelic, the near-death, the mystical, are variations on a single class of brain state, one that can be induced by chemical manipulation or by the extreme physiological conditions of dying, and that the sense of encountering something more real and more fundamental than ordinary life is a feature of that brain state, rather than evidence of something that exists beyond the brain. The second is the reverse, that all of these experiences converge on the same territory because that territory is real, and that the brain, under psychedelic compounds, under extreme stress, under the conditions of dying, is not generating a state, but accessing one, not producing an experience of vastness, but briefly ceasing to obstruct it. The neuroscience does not currently allow you to choose between these interpretations with confidence. What it allows you to say is that the convergence is real, that it is not coincidental, and that any account of consciousness that cannot explain it is an account of consciousness that is missing something important. The nature of that something is the deepest question in science. It has a name, and the man who gave it that name stood in front of a room full of scientists in 1995 and said something that none of them could answer, and that none of them have answered since. David Chalmers was 31 years old when he named the problem that has paralyzed the science of consciousness ever since. It was 1995, and he was presenting a paper at a conference in Tucson, Arizona, a gathering of philosophers, neuroscientists, and cognitive researchers that had been convened specifically to address the question of consciousness. Chalmers stood before the room and made a distinction that seemed, on the surface, modest. He separated what he called the easy problems of consciousness from what he called the hard problem. The easy problems, he was careful to explain, are not actually easy. They are enormously complex. Understanding how the brain processes sensory information, how it integrates data from different sources, how it directs attention, how it regulates behavior. These are formidable scientific challenges that will occupy researchers for generations. But they are, in principle, tractable. They are questions about function. Given enough time, enough data, and enough computing power, we can expect to answer them. They are engineering problems with engineering solutions. The hard problem is different in kind, not just degree. The hard problem asks why any of that functional processing is accompanied by experience at all. Why, when light of a particular wavelength strikes your retina and triggers a cascade of electrochemical signals that travel through your optic nerve and are processed by your visual cortex, do you experience the color red? Why is there something it is like to see it? A camera processes the same wavelength and records it. The camera does not experience anything. You do. The hard problem is the question of why. You can map every step of the neural process with perfect accuracy. You can identify every neuron that fires, every synapse that transmits, every region that activates. And when you have done all of that, the question remains completely untouched. Why is any of it accompanied by a felt, subjective, inner life? Why are you not, as Chalmers put it, a philosophical zombie, a being that processes information and generates behavior identically to a conscious person, but with nothing happening on the inside? The room in Tucson did not have an answer. 30 years later, neither does anyone else. This is not a fringe concern or a philosophical curiosity. Christoph Koch, who spent decades as chief scientist at the Allen Institute for Brain Science and has devoted his career to the empirical study of consciousness, has described the hard problem as the most fundamental unsolved question in all of science. Not neuroscience, all of science. More opaque, he has said, than the physics of black holes. More mysterious than the nature of dark matter. We know more about the large-scale structure of the universe than we know about the nature of the experience you are having right now, listening to these words. The dominant position in neuroscience, the position that most researchers in the field hold by default, often without examining it explicitly, is that consciousness is generated by the brain. It is what certain kinds of neural processing produce, in the same way that digestion is what the stomach produces. Damage the stomach and digestion is impaired. Damage the brain and consciousness is impaired. destroy the brain and consciousness ends. The correlation is so consistent, so well documented, so supported by a century of clinical observation and experimental evidence that most neuroscientists treat it as settled. Francis Crick, who co-discovered the double helix structure of DNA and spent the second half of his career on the problem of consciousness, stated the position in its starkest form. You, your joys and your sorrows, your memories and your ambitions, your sense of personal identity and free will, are in fact no more than the behavior of a vast assembly of nerve cells and their associated molecules. You are, he wrote, nothing but a pack of neurons. The evidence for this view is genuine and substantial. Brain injuries change personality in ways that are specific, predictable, and often devastating. Damage to the hippocampus destroys the ability to form new memories. Damage to a region called Broca's area destroys the ability to produce speech while leaving comprehension largely intact. Damage to the fusiform gyrus destroys the ability to recognize faces. The specificity of these correlations, the way that particular damage produces particular deficits with extraordinary reliability, is powerful evidence that mental functions are implemented in specific neural structures, and that those structures are both necessary and sufficient for the functions they support. The problem is that correlation is not mechanism. A century of neuroscience has established, beyond any reasonable dispute, that brain activity and conscious experience are correlated. Change the brain, and you change the experience. That is not in question. What remains entirely unexplained, what no theory, however sophisticated, has yet provided, is the mechanism by which physical processes in neural tissue give rise to subjective experience. Why does any of it feel like anything? Two major theories have been proposed in recent decades, and both have serious advocates and serious problems. Giulio Tononi at the University of Wisconsin-Madison developed integrated information theory, the proposal that consciousness is identical to integrated information, a mathematical quantity he calls phi. The more a system integrates information in ways that cannot be decomposed into independent parts, the more conscious it is. The theory is mathematically rigorous and makes specific predictions. It also implies that consciousness is a fundamental property of certain kinds of organized systems rather than something exclusively biological, that any sufficiently integrated information processing system has some degree of inner experience, which strikes many researchers as both philosophically interesting and deeply counterintuitive. Bernard Baars and Stanislas Dehaene developed global workspace theory, the proposal that consciousness arises when information is broadcast widely across interconnected brain regions, becoming available to multiple cognitive processes simultaneously. This explains the difference between conscious and unconscious processing in functional terms. It is elegant and well supported by experimental data. It describes, with considerable precision, how the brain distinguishes what it is conscious of from what it processes without awareness. Neither theory answers the hard problem. Integrated information theory tells you how much consciousness a system has, but not why integrated information feels like anything. Global workspace theory tells you which information becomes conscious, but not why broadcasting that information produces experience, rather than simply making it more widely available for computation. Both theories describe the architecture of consciousness with genuine insight. Neither bridges the gap between the physical and the felt. That gap, the explanatory gap, as the philosopher Joseph Levine named it, is where the question of death becomes most acute. If consciousness is generated by the brain, then the destruction of the brain is the destruction of consciousness. The generator is gone. Whatever was producing the experience ceases to produce it. Death is annihilation, not of the atoms, which are conserved, but of the pattern of experience. The lights go out because the thing that made them is gone. But if consciousness is generated by the brain, then terminal lucidity should be impossible. If consciousness is generated by the brain, then the verified perceptions of cardiac arrest survivors should not exist. If consciousness is generated by the brain, then the hard problem should be solvable, because we should be able to point to the mechanism and say, here is where the experience comes from. Here is how the neural process becomes a felt reality. We cannot. And that inability is not a temporary gap waiting to be filled by more data. It is a structural problem with the generative model itself, which is why an idea that was proposed not by a mystic or a philosopher, but by the father of American psychology, deserves more serious attention than it typically receives. William James delivered a lecture at Harvard in 1898. He was grappling with the same question that Chalmers would name a century later, and he proposed a way of holding it that the intervening years have not rendered obsolete. The brain, James suggested, may not generate consciousness. It may transmit it. The relationship between the brain and conscious experience may be the relationship between a prism and light. The prism shapes the light, refracts it, gives it specific colors and directions, but the prism does not create the light. Destroy the prism, and the light does not disappear. It simply passes through unmediated. Aldous Huxley extended this idea in 1954. He described the brain as a reducing valve, a mechanism whose function is not to produce consciousness, but to constrain it, to filter the overwhelming totality of possible experience down to the manageable trickle that allows us to navigate physical reality. Psychedelic compounds, he suggested, temporarily open the valve. They do not add something to consciousness. They remove the filter. Death, in this framework, removes the valve entirely. This is not a testable hypothesis in the strict scientific sense. It makes no specific predictions that would distinguish it from the generative model under ordinary experimental conditions. It is a philosophical framework, not a research program. Skeptics are right to note this. But here is what the skeptics cannot yet say. They cannot say the receiver model is refuted. They cannot say the evidence rules it out. The generative model is dominant not because it has been proven, but because it is the default assumption of a materialist science that regards the burden of proof as falling on anything that challenges it. Consider what the receiver model would predict, and then consider whether the predictions are consistent with the evidence. If the brain filters rather than generates consciousness, then damage to the brain should sometimes produce expansion rather than only reduction, states in which the filter fails and more of the signal comes through rather than less. That is precisely what psychedelic compounds appear to produce. That is precisely what the default mode network suppression under psilocybin appears to produce. If the brain filters rather than generates consciousness, then severe neurological damage should sometimes leave the underlying signal intact even when the filter is destroyed. Terminal lucidity, the return of full cognitive function in a brain that has been devastated by Alzheimer's disease, is exactly what that prediction describes. If the brain filters rather than generates consciousness, then the death of the brain should not be the end of experience. It should be its release. None of this proves the receiver model. These observations are consistent with it, not exclusive to it. A sufficiently creative materialist can construct alternative explanations for each of them, and some of those explanations are serious and worth considering. But the convergence of anomalies is accumulating. Terminal lucidity, verified near-death perceptions, the structural consistency of the dying experience across cultures with no shared framework, the hard problem, unresolved after a century of effort. Each of these is, individually, a puzzle with a potential materialist solution. Together, they constitute a pattern that deserves something more than dismissal. The question of whether consciousness can exist independently of the physical brain, whether the receiver model or something like it might actually be true, is no longer purely philosophical. It has become, at the edges of physics, an experimental question. And the physicist, who has come closest to making it one, is not primarily known for his work on consciousness at all. He is known for proving that black holes are inevitable, and for the Nobel Prize he received for doing so. His name is Roger Penrose. And the theory he developed, in collaboration with an anesthesiologist who had been watching patients lose consciousness under surgical conditions for decades, is the most ambitious and the most contested attempt to bridge the gap between quantum mechanics and the felt reality of being alive. Stuart Hameroff had spent years watching people disappear. Not die, disappear. Patients wheeled into the operating theatre, anaesthetic administered, and then something that had been present a moment before simply ceased to be present. The body remained. The brain continued its basic functions. The heart beat, the lungs drew air, the brainstem regulated everything that keeping a body alive requires. But the person was gone, and then, minutes or hours later, they came back. What precisely had left, and where had it gone? Hameroff was an anesthesiologist at the University of Arizona, and this question, which most of his colleagues treated as a practical matter rather than a philosophical one, had been nagging at him for years by the time he began examining the cellular architecture of the neurons he was chemically silencing. What he noticed was that the anesthetic molecules he worked with did not simply diffuse indiscriminately through neural tissue. They bound to specific structures inside the neurons themselves. Tiny hollow protein cylinders that form part of the internal scaffolding of virtually every cell in the body. They are called microtubules, and for most of the history of cell biology, they were regarded as purely structural, the beams and struts that give cells their shape, the tracks along which cellular cargo is transported. Useful, mechanical, unremarkable. Hameroff was not convinced they were unremarkable. In neurons specifically, microtubules do far more than hold the cell together. They regulate synaptic connections. They participate in signal processing. They control the dynamic restructuring of the neural architecture that underlies learning and memory. And the fact that anesthetic molecules that reliably eliminate consciousness without eliminating the brain's basic biological functions, targeted these structures specifically seemed to Hameroff like a clue that the field was not following. Roger Penrose arrived at the problem from the opposite direction entirely. Penrose is a mathematician and physicist at the University of Oxford, whose work spans general relativity, cosmology, and the foundations of quantum mechanics. He is most widely known for proving, in the 1960s, that the formation of black holes is a mathematical inevitability within Einstein's general relativity, work for which he received the Nobel Prize in Physics in 2020. But for decades, running in parallel with his physics, he had been developing an argument about consciousness that his colleagues in both physics and neuroscience found either fascinating or exasperating, depending on their disposition. His argument began with a problem in the foundations of mathematics. In 1931, the logician Kurt Gödel proved something that shook the mathematical community: that within any sufficiently complex formal system, there are true statements that cannot be proven within that system. This is Gödel's incompleteness theorem, and its implications extend beyond mathematics into the question of what kinds of processes can, in principle, be carried out by algorithms, by rule-following computational machines. Penrose's reading of Gödel was this: human mathematicians can recognize the truth of Gödelian statements that no algorithm can prove. This means that whatever human mathematicians are doing when they do mathematics, it cannot be purely computational. It cannot be fully described as the execution of an algorithm. And if human cognition is not purely computational, then the brain, the physical system implementing human cognition, must be doing something that goes beyond classical computation. The only domain of physics that goes beyond classical computation in the relevant sense, Penrose argued, is quantum mechanics. Specifically, it is the process by which quantum superpositions, states in which a quantum system exists in multiple configurations simultaneously, resolve into a single definite outcome. This resolution, Penrose proposed, is not caused by observation or measurement in the conventional sense. It is an objective physical process driven by the curvature of space-time at quantum scales. He called it objective reduction. And then he met Hameroff, who had been looking at microtubules. The theory they developed together is called orchestrated objective reduction, ORC-OR for short. Its central claim is that quantum superpositions build up within the tubulin proteins that make up microtubular walls inside neurons. These superpositions are orchestrated, shaped and structured by the biological activity of the neural network. When they reach a threshold defined by quantum gravitational effects, they undergo objective reduction. They collapse. And each collapse in this framework is a moment of conscious experience. Consciousness, on this account, is not computed by the brain. It is not generated by the brain in the way that a furnace generates heat. It arises from quantum events occurring at the intersection of biology and the fundamental structure of space-time, events that the brain's microtubular architecture is specifically organized to support. The brain does not produce consciousness. The brain is the instrument through which consciousness, as a feature woven into the quantum geometry of the universe, is accessed and expressed. The scientific community's initial response was largely dismissive, and the objection was straightforward. The brain is warm, wet, and subject to constant thermal noise. Quantum coherence, the maintenance of quantum superpositions, is extraordinarily fragile. It is typically observed only at temperatures approaching absolute zero, in conditions of near-total isolation from environmental disturbance. A biological brain operating at 37 degrees Celsius, saturated with biochemical activity, seemed like precisely the kind of environment in which quantum effects would be instantly destroyed rather than sustained long enough to do anything useful. This objection was serious. For years, it appeared decisive. Then quantum biology began finding things that the objection said should not exist. In 2007, Graham Fleming and his colleagues at the University of California, Berkeley, published evidence of quantum coherence in the process of photosynthesis, the mechanism by which plants and bacteria harvest light energy and convert it into chemical energy. Photosynthesis operates at biological temperatures in wet cellular environments, and yet the energy transfer that lies at its heart appeared to involve quantum superpositions maintained long enough to select the most efficient pathway through the molecular machinery. The warm, wet environment was not destroying the quantum effects. It appeared, somehow, to be exploiting them. The navigation system of migratory birds followed. Henrik Moritzen at the University of Oldenburg produced compelling evidence that European robins use quantum entanglement in specialized proteins in their eyes to detect the direction of the Earth's magnetic field. A quantum biological compass operating in a living organism at body temperature. Quantum tunneling was then demonstrated in enzyme catalysis. One by one, the examples accumulated, and the argument that biology is simply the wrong kind of environment for quantum effects began to look less like a principle and more like an assumption that the data was steadily undermining. The experimental support for ORC-OR specifically has been building. A study published in 2024 examined the effect of a drug called epothalone B on the onset of anesthesia in rats. Epothalone B stabilizes microtubules. It binds to them and makes them more structurally rigid. If microtubules were purely mechanical structures with no role in consciousness, stabilizing them should have no effect on the process by which consciousness is lost under anesthesia. The rats treated with epothalone B took over a minute longer to lose consciousness than the control animals. The implication was direct. Microtubules play an active role in maintaining the conscious state, not merely a structural one. In 2025, Hameroff and colleagues published what they described as direct experimental evidence for quantum effects in microtubules at room temperature, along with magnetic resonance imaging data suggesting the existence of a macroscopic quantum state in the human brain associated with consciousness. The paper argued that ORC-OR resolves two of the most persistent problems in consciousness science: the binding problem, the question of how the brain integrates disparate sensory inputs into a single unified experience, and the problem of how consciousness can have any causal effect on the physical world if it is merely a byproduct of neural computation. At the Gran Sasso National Laboratory in Italy, deep underground where cosmic ray interference is minimized, researchers have been testing models of gravity-related quantum collapse. The simplest versions of these models have been ruled out. Penrose's more sophisticated formulation has not been excluded. The experiments continue. ORC-OR remains contested. Many neuroscientists consider it speculative, and the gap between the evidence accumulated so far and a full confirmation of the theory is substantial. That is an honest assessment, and it should not be papered over. But here is what ORC-OR does that no competing theory of consciousness does. It makes specific, testable, falsifiable predictions about the physical processes underlying conscious experience. It connects consciousness to the most fundamental level of physical reality. And if it is correct, even approximately correct, the implications for what happens at death are staggering. The implication begins with a principle in quantum information theory called the no-hiding theorem. Proved by Samuel Brownstein at the University of York and Aaron Patti, the no-hiding theorem establishes that quantum information cannot be destroyed. It can be scrambled. It can be dispersed across a system in ways that make its practical recovery impossible. It can be transformed beyond any reasonable hope of reconstruction, but it cannot be annihilated. The mathematics of quantum mechanics does not permit it. Quantum information is, in a precise and physical sense, conserved. This is not an abstract philosophical claim. It is a theorem with a proof, and its implications are the same as the implications of any mathematical truth. They hold regardless of whether we find them convenient. The black hole information paradox is the most famous arena in which this principle has been tested. Stephen Hawking's original calculation suggested that information falling into a black hole is permanently lost as the black hole evaporates. Destroyed, gone, irretrievable. He held this position for decades. In 2004, he publicly conceded that he had been wrong. Information is not destroyed by black holes. It is scrambled and eventually returned, because the laws of quantum mechanics do not permit genuine information loss. The universe, even at its most extreme, preserves information. Hameroff has been explicit about what he believes this means for the quantum information that, on the ORC-OR account, constitutes conscious experience. When a person dies, he has said, the quantum information in their microtubules does not disappear. It dissipates into the universe. If the patient is resuscitated, that information can flow back into the microtubules and the person reports a near-death experience. If resuscitation does not occur, the quantum information exists outside the body. Perhaps, he has suggested, indefinitely. Penrose is more cautious. He does not use the language of souls. He has said, carefully, that the relationship between consciousness and quantum gravity is something we are only beginning to understand, and that he would not dismiss the possibility that consciousness has a deeper relationship to the physical universe than current neuroscience assumes. That careful formulation, from the man who proved black holes are inevitable and won a Nobel Prize for doing so, deserves to be taken seriously. There is one further framework to consider before this investigation turns to the oldest maps of the terrain we have been exploring. It was proposed not by a physicist, but by a biologist, a stem cell researcher whose credentials in mainstream science are impeccable and whose conclusions are among the most radical that a credentialed scientist has advanced in recent memory. Robert Lanza has published hundreds of peer-reviewed papers. He has pioneered techniques in regenerative medicine. Time magazine named him one of the 100 most influential people in the world. And in 2009, he published a book arguing that consciousness is not a product of the universe. The universe, he argued, is a product of consciousness. The argument begins with the double-slit experiment. Fire individual particles, photons, electrons, at a barrier with 2 slits in it. Behind the barrier is a screen that records where each particle lands. If particles are simply particles, you expect 2 bands on the screen, one behind each slit. What you get instead is an interference pattern, a series of alternating bands that is characteristic of waves, as if each particle somehow passed through both slits simultaneously and interfered with itself. Each particle behaves as a wave of probability, occupying multiple positions at once until it is detected, at which point the probability wave collapses and the particle lands in a specific location. Now add a detector at the slits to observe which slit each particle passes through. The interference pattern vanishes. The particles behave like particles. 2 bands. The act of observation changes the outcome. This is not disputed. It has been reproduced thousands of times in laboratories around the world. It is one of the most rigorously established results in all of physics, and it has never been satisfactorily explained. Lanza's argument is that it cannot be explained within a framework that treats the physical world as existing independently of observation, because the experiment demonstrates that the physical world, at the level at which its fundamental constituents operate, does not behave independently of observation. The observer is not a passive recorder of a reality that exists whether or not anyone is looking. The observer participates in the reality that is observed. If consciousness is not produced by the physical world, but is in some sense constitutive of it, if the observer is not an emergent property of matter, but a precondition for matter to have definite properties at all, then the death of any particular biological body is not the death of consciousness. It is the dissolution of one particular vessel through which consciousness was expressing itself. The criticisms of this position are serious. Lawrence Krauss and others have pointed out that the observer in quantum mechanics does not need to be conscious. A detector, a measuring device, any physical system that interacts with a quantum system and records the outcome can collapse the wave function. Consciousness may not be special in the way Lanza requires. Biocentrism, as a scientific theory, makes few falsifiable predictions and has not generated an experimental research program of the kind that could confirm or refute it. These are legitimate objections. Biocentrism sits closer to philosophy than to testable science, and this investigation will not overstate its evidential status. But it takes the observer problem seriously. It takes the hard problem of consciousness seriously, and it arrives, by a different route, at the same destination that the receiver model and Orch-Orr approach from their respective directions. The possibility that the death of the brain is not the death of what the brain was hosting. Three frameworks: the receiver model, orchestrated objective reduction, and biocentrism, converging on the same question from physics, from biology, and from philosophy. None of them proven, none of them refuted, all of them pointing at the same gap in what we think we know. That gap is not new. Human beings have been mapping it for thousands of years. The oldest maps are not in scientific journals. They are carved into the walls of tombs, painted on sheets of papyrus, and written in languages that were already ancient when the modern world began. The most detailed map ever drawn was completed along the banks of the Nile over the course of 2,000 years by a civilization that treated death not as a mystery to be solved, but as a journey to be prepared for. And the preparation, it turns out, required engineering. The ancient Egyptians did not believe in the afterlife the way we use that word today. Belief implies uncertainty, a position held in the absence of proof, a hope extended beyond the available evidence. The Egyptians did not hope the dead continued. They knew it. And because they knew it, they approached death the way any practical civilization approaches a known and inevitable challenge. They engineered for it. The pyramids are the most visible expression of this, but they are not the most revealing one. The most revealing expression is a collection of texts, evolving over 2,000 years, available eventually to anyone who could afford a copy, that functioned as a technical manual for the most important journey a person would ever take. We call it the Book of the Dead. The Egyptians called it something more precise: the chapters of going forth by day. To understand what that manual was for, you first need to understand what the Egyptians believed a human being was. Because their answer was more complex than ours, and in at least one respect more honest. A person, in Egyptian understanding, was not a single unified entity. You were several things woven together, and death unraveled them. The ka was your vital force, the animating energy that distinguished a living body from a corpse, present from the moment of birth and requiring sustenance after death in the form of offerings left by the living. The ba was your personality, your individual character, the specific texture of who you were. It was depicted as a human-headed bird because it was free. It could move between the world of the living and the world of the dead, visit the tomb, travel through the underworld, see the sun. But the Ba needed somewhere to return to. It needed an anchor in the physical world. Without one, it would dissipate. This is why mummification existed. Not as ceremony, not as reverence for the body in any sentimental sense, but as infrastructure. The preserved body was the Ba's home base, the structure it returned to between its journeys, the fixed point around which the afterlife journey could be organized. Destroy the body, and you destroyed the Ba's ability to complete the process. The ultimate goal was the Ak, the transfigured, luminous, eternal being that the Ka and Ba formed together when they were successfully reunited in the afterlife. The Ak was what you became if the journey went well. If it did not, you became nothing at all. Not punished, not consigned to suffering, erased. The journey between death and becoming an Ak passed through a terrain the Egyptians called the Duat, the underworld. And the Duat was not a metaphor. It was a place, described in visceral physical detail across thousands of years of funerary text, with the specificity of something that its describers believed to be as real as the Nile. It was enormous. It was terrifying. It was organized, vast labyrinthine caverns threaded with rivers of fire, lakes of boiling liquid, corridors that narrowed to passages barely wide enough to pass through, guarded at every junction by creatures of specific and documented appearance, serpents that breathed flame, gatekeepers armed with knives, five-headed entities whose names had to be spoken correctly, or the path ahead would close. Every challenge in the Duat was surmounted not through strength or heroism, but through knowledge. The dead traveller who knew the name of a guardian could pass. The one who did not was stopped. This is why the Book of the Dead existed. Foy Scalf, whose scholarship on the text at the Oriental Institute of the University of Chicago represents some of the most careful work done on the subject, has described it as primarily a transformational document rather than a navigational one. It was not merely a map. It was a manual for becoming something that the living self was not yet capable of being. It contained roughly 192 known spells, hymns, and incantations, each serving a specific function in the passage through the Duat. The text evolved over 2 millennia. Its earliest ancestors were the pyramid texts, carved into the walls of royal tombs around 2,400 years before the Common Era, available only to pharaohs, their content treating the king's passage to divine status as something practically achievable rather than merely hoped for. Over centuries, these became the coffin texts, accessible to the nobility. By the New Kingdom, around 1550 years before the Common Era, the Book of the Dead had become a commercial product. Scribes produced copies for anyone who could pay, with blank spaces for the customer's name to be filled in. The afterlife, in Egypt, was eventually democratized. At the end of the journey through the Duat, the traveller arrived at the Hall of Ma'at, the Hall of Truth. And here the text reaches the moment that has lodged itself in the human imagination for 4,000 years. The hall was presided over by Osiris, seated on his throne, a god who had himself been killed and resurrected, and whose own story gave the Egyptians a template for what death and return could mean. The walls were lined with 42 divine judges. The goddess Ma'at, whose name meant truth and whose emblem was a single white feather, was present. And at the center of the hall stood a golden scale attended by Anubis, the jackal-headed deity who guided the dead through the underworld and whose role at this moment was purely technical, to ensure the weighing was accurate. The deceased was required to recite the negative confessions, a litany of 42 declarations of innocence, one for each judge. I have not stolen. I have not lied. I have not caused suffering. I have not taken what belongs to the gods. Each declaration was addressed to a specific judge by name. Each had to be spoken in full. And then the weighing. Anubis placed the heart of the deceased on one pan of the scale. On the other pan, he placed the feather of Ma'at. The heart, in Egyptian understanding, was the seat of consciousness, the organ that contained the complete record of a life, every act and every omission, every truth told, and every deception maintained. It was the moral archive of the self. If the heart and the feather balanced, if the life recorded in the heart was one of sufficient truth and integrity, the scale tipped in the traveller's favour. The 42 judges declared them justified. They were permitted to enter Sekhet Aru, the field of reeds, an idealized Egypt of eternal springtime, blue rivers, golden harvests, and the company of those who had gone before. If the heart was heavier than the feather, weighted down by cruelty, dishonesty, the accumulated choices of a life lived in bad faith, Amit was waiting. Part crocodile, part lion, part hippopotamus, she crouched beside the scale. She devoured the heavy heart, and the person it belonged to ceased to exist. Not punished, not sent somewhere terrible, gone. The name erased, the self dissolved. Hold that image alongside what near-death experience survivors describe, and the structural resonance is not subtle. The panoramic life review. The experience of reliving the entire life simultaneously from the perspective of everyone affected. The moral weight of every action and every choice, felt rather than merely remembered. The sense that the evaluation is not being performed by an external judge, but is arising from the nature of the life itself. The Egyptians encoded this structure into stone and papyrus 4,000 years ago. The researchers conducting the AWARE studies documented it in cardiac arrest survivors in the 21st century. The patients who reported these experiences had no knowledge of Egyptian funerary theology. The Egyptians had no knowledge of what dying brains do under EEG monitoring. The structure appeared in both places independently. Whether it appeared because both were encoding the same neurological event, or because both were glimpsing the same underlying reality, is a question this investigation has not yet answered and will not pretend to. What can be said is that the pattern is real, and that it runs deeper than coincidence. Half a world away, and nearly 2 millennia after the New Kingdom scribes were producing their commercial copies of the Book of the Dead, a different civilization arrived at a different kind of manual. It was not carved into walls. It was read aloud. And unlike the Egyptian texts, it was not addressed to the judges and the gods waiting on the other side of death. It was addressed to the person who was dying. The Bardo Thodol, known in the West as the Tibetan Book of the Dead, was attributed to the 8th century Buddhist master Padmasambhava and compiled in its present form in the 14th century. It was a terma, a treasure text, hidden until the world was ready to receive it and revealed when the time was right. But its function was unlike any other sacred text in any tradition. You read it to someone while they were dying. You continued reading it after their heart stopped. Because in the Tibetan Buddhist understanding of what death is, the moment the heart ceases to beat is not the end of the process. It is the beginning of a new and extraordinarily consequential phase, one in which the consciousness of the recently deceased is more vulnerable and more potentially free than it has ever been during life. The word bardo means intermediate state. It refers to any gap between one condition and another. Sleep is a bardo. Dreaming is a bardo. Death is the most significant bardo of all, the transition between one life and whatever comes next. And the Bardo Thodol was a guide for navigating it. The Tibetan model of death differs from the Egyptian one in a way that reaches deep into the philosophical foundations of both traditions. In Egypt, the afterlife was a physical journey through a physical terrain. The dangers were external. The gatekeepers were real entities whose names had to be known. The traveler moved through space. In Tibet, the afterlife is entirely internal. Everything that is experienced after death is a projection of the dying mind. There are no external demons. There are no real gatekeepers. There is only consciousness, stripped of its biological housing, confronting its own nature without the mediation of a body. That confrontation unfolds in 3 stages. The first is the Chikai Bardo, the process of dying itself. The Tibetan teachers described it in precise physiological detail, mapping what they understood as the dissolution of the body's elements in sequence. Earth dissolves into water. The body feels impossibly heavy. Vision blurs. The sense of being grounded in physical reality begins to fail. Water dissolves into fire. The mouth dries. The bodily fluids slow. Warmth begins to leave the extremities. Fire dissolves into air. The body's heat gathers and then fades. The breath becomes shallow. The rhythm of life begins to irregular. Air dissolves into consciousness. The breath stops. The body is still. And then, at the exact moment of final dissolution, at the instant when the last element releases and the process of dying completes, the clear light appears. This is the central moment of the entire text, and it is worth understanding with precision what the Tibetan teachers meant by it. The clear light is not a light that is seen. It is not an external phenomenon encountered by the consciousness of the dying person. It is the fundamental nature of mind itself, pure awareness, without content, without boundary, without the distinction between observer and observed, that structures all ordinary experience. It is what consciousness is when it is no longer constrained by a body, a self, a history, or a story. Vast, luminous, empty of everything except the fact of awareness itself. The Bardo Thodol's instruction at this moment is unambiguous. Recognize it. If the dying consciousness can recognize the clear light as its own true nature, not as something encountered, but as something that it is, liberation is instantaneous. The cycle of rebirth ends. There is no further journey. The self dissolves into the infinite and does not reform. Almost no one manages it, not because the clear light is hostile or difficult to find, but because it is too vast. A consciousness that has spent an entire lifetime organized around a self, around preferences and aversions, around the story of being a particular person in a particular body with a particular history, encounters something completely structureless and completely boundless and recoils. It is too much. It is too open. The habits of a lifetime have no purchase in it. And so the second stage begins. The Chonyid Bardo is the arising of visions. In the days following death, the text is organized as a series of instructions for each day of this stage. The consciousness of the deceased begins to experience appearances. First, the peaceful deities, radiating light of overwhelming beauty in 5 colors, each associated with a different aspect of awakened consciousness. They arrive offering liberation. But alongside each peaceful light, there is a duller, more comfortable light that pulls in a different direction, toward the familiar and the habitual. Then the wrathful deities, the same enlightened beings now wearing masks of ferocity, fanged, flame-wreathed, brandishing weapons, their faces contorted into expressions of terrifying power. They arrive in the second week, and the consciousness that could not recognize the clear light and could not reach for the peaceful lights now encounters the most alarming possible appearances. The central teaching of the Chonyid Bardo is this: none of it is real. The peaceful deities and the wrathful ones are both projections of the dying mind, appearances generated by the habitual patterns of the consciousness experiencing them, reflections of its own nature that it cannot yet recognize as such. The beings are not external. They are not coming from anywhere. They arise from within, and if that recognition can be made, if the consciousness can see that the wrathful deity is itself wearing a mask, liberation is still possible. Carl Jung, in his 1935 psychological commentary on the first Western translation of the text, saw in the Bardo visions a precise map of the unconscious mind. The peaceful and wrathful deities, he argued, correspond to the archetypal figures that appear in the dreams and psychoses of Western patients, not because Tibetan Buddhism and Western psychology share a doctrine, but because both are describing the same deep structures of the human psyche. The Bardo, in Jung's reading, is the mind confronting its own contents without the organizing structure of the ego to mediate them. Whether Jung's reading is correct or not, the phenomenological overlap between what the Bardo Thodol describes and what the research discussed in earlier sections has documented is difficult to dismiss. The dissolution of self at the moment of death, the clear light encountered at the threshold, overwhelming. boundless, more real than ordinary life. The entity encounters of dimethyltryptamine and 5-MeO-DMT. The panoramic life review. The sense of reaching a boundary and being returned. These descriptions were assembled from clinical data collected in hospitals, from psychedelic research conducted under federal oversight, and from a 14th century Tibetan text read aloud to the dying in mountain monasteries. They are describing the same territory. The Tibetan teachers did not have EEG machines. They did not have cardiac monitors or intravenous dimethyltryptamine or a standardized near-death experience scale. What they had was centuries of careful attention to the process of dying, a tradition of contemplative practice designed specifically to prepare the mind for the threshold moment, and a text that tried to tell the dying person what they were about to encounter. What they produced matches the neuroscience with a precision that neither tradition could have planned. That is the pattern. It keeps appearing, and it is not finished appearing yet. The Norse did not promise paradise, they promised purpose. In the mythology of the Viking Age, the afterlife was not a reward for virtue or a destination earned through moral conduct. It was a posting, an assignment. The universe was going to end, not as a possibility, not as a distant theological abstraction, but as a certainty as fixed as the rising of the sun, and the dead were needed for what was coming. The story begins with how you died. A warrior who fell in battle was visited by the Valkyries, the choosers of the slain, female figures who rode across the battlefield and selected the bravest of the fallen. Half of those chosen were taken to Valhalla, the great hall of Odin. The other half went to Folkvanga, the field of the goddess Freya. Those who died of illness, of old age, of anything other than combat, went to Hel, a realm presided over by a goddess of the same name, described as half-living flesh and half-decaying corpse. Hell was not punishment. It was simply the default, a cold, dim, joyless continuation of existence, without glory and without purpose. What mattered, in Norse cosmology, was not how you lived, it was how you died. This distinction sets Norse eschatology apart from virtually every other afterlife tradition in human history, and it is worth sitting with for a moment. The Egyptian hall of Ma'at weighed the heart, the accumulated moral record of a life. The Islamic mizan balanced good deeds against sins. The Greek judges evaluated the character of the deceased. The Hindu doctrine of karma tracked the ethical weight of actions across lifetimes. In every one of these frameworks, what you did determined where you went. In Norse tradition, what determined where you went was the manner of your departure. The logic was cosmic rather than moral. Valhalla existed for a specific reason. Every morning the Einherjar, the warrior dead housed in Odin's hall, rose, dressed in their armor, and fought each other to the death. Every evening they rose again, healed, and sat down to an endless feast. They ate the flesh of a magical boar that was slaughtered and restored each day. They drank mead that flowed from the udders of a goat that fed on the leaves of Yggdrasil, the world tree. This was not leisure, this was training. Because Ragnarok was coming, the final battle, the death of the gods, the serpent Jormungandr rising from the ocean to poison the sky, the wolf Fenrir swallowing the sun, Odin falling, Thor falling, the world tree shuddering, and the earth sinking into the sea. The Norse knew their universe would die, and they built their entire conception of the afterlife around the requirement that the dead be ready for it. When Ragnarok came, the doors of Valhalla, 540 of them, each wide enough for 800 warriors to march through abreast, would open, and the Einherjar would pour out to fight alongside the gods. They would lose. That was known. The Norse imagined a cosmos that ends in defeat, and they honored it anyway. The ship burials and the cremation pyres that marked Norse funerary practice were not merely ceremonial. They were logistical preparation, the body equipped with weapons, food, and companions for the journey, the flames or the water serving as transportation rather than disposal. The dead needed to arrive equipped, travel south from Scandinavia, across the North Sea, through the Straits, into the Mediterranean. and the afterlife changes character entirely. The Norse cosmos was organized around a final battle. The Greek cosmos was organized around a bureaucracy. When a Greek died, the soul descended to the realm of Hades. It was a journey that required a fare. A coin, an obol, was placed in the mouth or on the eyes of the dead before burial. Without it, the soul could not pay Charon, the ferryman who crossed the river Styx, and would be condemned to wander the near shore for 100 years, belonging neither to the living nor to the dead. The destination, once across, depended on what Minos, Rhadamanthus, and Iarchus determined. These were the three judges of the underworld, and their evaluation was moral in the way the Norse system explicitly was not. The genuinely virtuous, the heroic, and the particularly favored of the gods were assigned to Elysium, a realm of eternal sunlight, perfect ease, and effortless joy. The ordinary dead, neither outstandingly good nor outstandingly wicked, went to the Asphodel Meadows, grey, quiet, and endlessly monotonous, a faded echo of life drained of its colour and urgency. And those who had committed genuine evil, or who had personally offended the gods, went to Tartarus. Tartarus was not merely unpleasant, it was designed. The punishments were specific, eternal, and precisely fitted to the crime. Sisyphus, who had cheated death and mocked the gods, pushed a boulder up a hill for eternity and watched it roll back down each time he neared the summit. Tantalus, who had served his own son as a meal to the gods, stood in a pool of water beneath branches heavy with fruit, and the water receded when he bent to drink, and the fruit withdrew when he reached for it. Eternal proximity to what you most desire. Eternal denial. The Greeks embedded death into the cycle of nature in a way that the Norse did not. Persephone, daughter of Demeter, abducted by Hades and taken to the underworld. Demeter's grief rendering the earth barren. The compromise reached, half the year below, half above. When Persephone descends, winter comes. When she returns, the earth flowers. Death and renewal as the same motion, the same breath. Orpheus descended into the underworld to retrieve his dead wife Eurydice, the only mortal ever to charm Hades with music alone. The god agreed. She could follow Orpheus back to the living world on one condition. He must walk ahead and not look back until they reached the surface. He almost made it. At the last possible moment, overcome by doubt, he turned. Eurydice was pulled back into the darkness forever. The myth of Orpheus is not a story about failure. It is a story about the nature of death, the insight that the dead cannot be retrieved, that the threshold, once crossed, resists reversal, and that the desire to undo death is one of the most human impulses imaginable and one of the most reliably tragic. These two traditions, the Norse and the Greek, are among the best documented afterlife mythologies in the Western record. But they are not remotely alone. In ancient Mesopotamia, the dead descended to Kur, a dusty underworld where all souls lived as diminished shadows, regardless of how they had lived, eating clay and drinking murky water. In Hindu tradition, Yama, the god of death, escorted the soul to Yamaloka for judgment before rebirth, according to the karma accumulated in life. In Aztec tradition, the dead navigated 9 layers of the underworld over 4 years before reaching their final rest. The nature of the journey determined not by morality, but by the manner of death. Warriors and women who died in childbirth went directly to a paradise accompanying the sun. In indigenous Australian traditions, the spirit returned to the dreaming, the eternal creative dimension that underlies and generates physical reality, from which individual lives emerge and to which they return. Different cosmologies, different beings, different geographies of the beyond. But beneath the surface differences, a skeleton that keeps reappearing, the journey. Every tradition describes a passage, a physical or metaphysical movement from one state to another. Death is not an endpoint, but a transition, and the transition requires navigation. The guide. Anubis leading the dead through the Duat. Hermes conducting souls to the underworld in Greek tradition. the Valkyries escorting the chosen to Valhalla, Yama receiving the dead in Hindu belief. The beings of light that near-death experience survivors describe meeting at the threshold. Across every tradition examined here, the dying are not alone. Something or someone accompanies them. The moral evaluation, the Egyptian weighing of the heart, the Islamic mizan, the Buddhist karmic reckoning, the Greek judges, the panoramic life review of the cardiac arrest survivor. The structure is consistent across traditions that had no contact with one another. At the threshold of death, what you did in life is confronted in full. The multiple destinations, Elysium and Tartarus, Valhalla and Hell, the field of reeds and dissolution in the jaws of Amit, Jannah and Jahannam. The features of this divergence vary, but the existence of divergence, the idea that what comes next is not the same for everyone, appears in virtually every tradition that has mapped the territory. And the importance of what the living do for the dead, the coin for Charon, the offerings left at Egyptian tombs to sustain the Ka, the prayers read aloud in the bardo, the Viking ship burial stocked with provisions. Every tradition insists that the living have a role to play in the passage of the dead, that the relationship between the living and the dead continues beyond the moment of death, and that its terms matter. These patterns predate any contact between the civilizations that produced them. The Norse never met the Egyptians. The Aztecs never encountered the Greeks. The Aboriginal Australians developed their understanding of death in isolation from every Eurasian tradition. And yet, the architecture recurs. There are two ways to hold this. The first is neurological. If the dying brain generates a consistent set of experiences, the gamma surge, the disinhibition, the dimethyltryptamine release, the panoramic life review, then every culture that has ever paid careful attention to its dying members is encoding the same biological event in the symbolic language available to it. The guide is universal because the sense of accompaniment is generated by the same neural processes in every dying brain. The moral evaluation is universal because the life review is a product of the same hippocampal activation regardless of cultural background. The multiple destinations are universal because the sense of divergent possibility at the threshold is a feature of the dying experience itself. The second way is the reverse. The patterns recur not because they are reflections of a neurological event, but because they are independent observations of a shared reality. Every civilization has been paying attention to the threshold of death for as long as it has existed, and every civilization has been seeing the same things, because those things are there. The neuroscience does not allow you to choose between these interpretations with confidence. The mythology does not resolve the question. What both of them together do is make the question impossible to dismiss. Now we need to leave the world of the dead entirely and return, briefly, to the physical reality of what happens to the body when the person has gone. Because before this investigation can arrive at its conclusions, it needs to confront the most certain thing of all, not what consciousness might or might not survive, but what the matter that constituted you unambiguously becomes. Your heart stops. Your brain, after its final surge, goes silent. And the body that housed everything you were begins, immediately and irreversibly, to dissolve back into the world it came from. Within minutes of cardiac arrest, the blood that circulated through the capillaries near the surface of your skin drains away. The skin pales. This is called pallor mortis, and it happens within the first quarter of an hour. Simultaneously, the metabolic processes that generated the heat of your living body cease, and your temperature begins to fall toward that of the surrounding air, roughly 1.5 degrees Fahrenheit per hour under normal conditions. It takes between 12 and 20 hours for a body in a cool room to reach ambient temperature. Forensic scientists call this algor mortis, and they use it to estimate time of death with considerable accuracy. Gravity begins its work. Without the heart to push blood through the circulatory system, blood obeys the same physical law as any liquid and pools in the lowest parts of the body, wherever they happen to be, given the position of the corpse. The pooling creates a dark purplish discoloration visible through the skin, called livor mortis, and its pattern can tell a forensic investigator whether a body has been moved after death. If the discoloration does not match the body's current position, someone changed something. Rigor mortis arrives between 2 and 6 hours after death. The mechanism is molecular. In a living muscle, the proteins actin and myosin bind together to produce contraction and then release when a molecule called adenosine triphosphate, the energy currency of the cell, separates them. Without the heart delivering oxygenated blood, adenosine triphosphate production ceases. The actin and myosin filaments bind and cannot release. The muscles lock. The stiffness begins in the smallest muscles first, the eyelids, the jaw, the fingers, and progresses through the body over the course of roughly 12 hours until every voluntary muscle is rigid. It holds for 24 to 84 hours before the decomposing tissue breaks down the bond and the body relaxes again. These are the visible changes. The invisible ones are more radical. Inside the cells, without oxygen, the chemistry that maintained every cellular membrane begins to fail. The cells become acidic, their membranes rupture, and the enzymes that were carefully contained inside them, enzymes whose job in life was to break down food and metabolic waste, spill into the surrounding tissue and begin digesting whatever they encounter. The pancreas, densely packed with the most powerful digestive enzymes in the body, is typically the first organ to consume itself. This process is called autolysis, self-digestion. The body begins, at the cellular level, to take itself apart. Then the bacteria. In life, roughly 39 trillion bacterial cells inhabit the human gut, held in careful balance by an immune system that maintains the terms of their tenancy. The moment the immune system shuts down, the terms dissolve. The bacteria do not register the death of the organism they inhabit. They register only that the barriers that once contained them are gone. They spread into the bloodstream, the organs, the tissue. They consume what they encounter and produce gases as they do, hydrogen sulfide, methane, ammonia, that cause the body to bloat and swell within days. The characteristic chemistry of decomposition follows, and with it, the ecological cascade that begins to draw the external world in. What happens next is not decay, it is return. Forensic anthropologists who study this process at research facilities, sometimes called body farms, have documented what a decomposing body does to the soil around it. The effect is dramatic. Nitrogen concentrations spike. Microbial diversity explodes. Plant growth in the immediate area becomes measurably more vigorous and persists at elevated levels for years after the body has fully decomposed. A human body in death does not simply end. It generates a burst of ecological energy that radiates outward from the point of return, feeding new life with the concentrated chemistry of an entire human existence. Green burial and human composting are practices built around this reality. Rather than sealing the body in metal and concrete, which is to say, rather than fighting the process, these approaches work with it. A body returned to shallow soil without chemical preservation decomposes fully and ecologically. Human composting, now legal in a growing number of jurisdictions, accelerates the process using thermophilic bacteria and organic materials, transforming a human body into nutrient-rich soil in 30 to 60 days. You become, quite literally, the ground from which new life grows. And beneath all of this, beneath the biology of return, beneath the chemistry of dissolution, is a truth that no tradition and no science disputes. Every atom in your body was made somewhere else. The hydrogen atoms in the water that constitutes roughly 60% of your body were formed in the first 3 minutes after the Big Bang, 13.8 billion years ago, in the initial nucleosynthesis that followed the birth of the universe. Every heavier element, the carbon in your muscles, the nitrogen in your DNA, the calcium in your bones, the iron in your blood, was forged in the interior of a massive star. Stars that burned for millions of years, fusing lighter elements into heavier ones in their cores, and then exploded as supernovae, scattering their elemental contents across the galaxy. That debris drifted through space for billions of years, condensed into new solar systems, formed planets, and eventually became, through a chain of chemical and biological processes, whose full complexity we are still mapping, you. Your atoms are older than the Earth. They were old when the first self-replicating molecule divided in a warm pool 3.8 billion years ago. The calcium in your right hand may have come from a different supernova than the calcium in your left. When you die, those atoms do not go anywhere new. They rejoin the cycle they were always part of. The carbon cycle, the nitrogen cycle, the water cycle, the slow geological and biological redistribution of matter through the biosphere that has been operating without interruption since the first complex chemistry emerged on this planet. The atoms that were you will be incorporated into soil, into plants, into insects, into the bodies of other organisms within a year of your death. A tree growing above a grave is, in a precise chemical sense, partly constructed from the person buried beneath it. The first law of thermodynamics states that energy cannot be created or destroyed, only transformed. Your body generates roughly 20 watts of electrochemical energy. When the body dies, that energy is released as heat, as chemical energy absorbed by the organisms that decompose you, as the potential energy stored in the nutrients that feed what grows above you. It does not vanish. It continues, in different forms, in different vessels, for as long as the universe continues. In a purely materialist framework, this is the afterlife. Not a place, not a state, a process. The redistribution of the matter and energy that was temporarily organized into you, back into the ongoing story of life on Earth. Whether that redistribution is the whole story, whether the pattern that was you, the information that constituted your consciousness, your memories, your sense of being a specific someone moving through time, whether that persists in any form beyond the dissolution of its biological substrate, is the question that everything examined in this investigation has been circling. We are almost ready to face it directly. Nobody grieves the carbon. When someone you love dies, the loss you feel is not the loss of their atoms. It is not the loss of the calcium or the iron or the nitrogen that will be returned to the soil within the year. The atoms were never really theirs to keep, and somewhere beneath the grief, you know this. What is mourned is something else. Something more specific and more irreplaceable than any element on the periodic table. What is mourned is the pattern, the particular arrangement of 86 billion neurons connected by approximately 100 trillion synaptic connections that stored a specific life, a specific way of seeing, a specific voice, a specific set of memories stretching back to childhood, a specific manner of laughing at something unexpected. The information encoded in that architecture, the self that the architecture sustained. This is the hardest part of the materialist account of death, not the recycling of the atoms. That can be held with a kind of poetic acceptance, even a kind of beauty. What is harder is the implication that the pattern dissolves irreversibly, that the neural networks degrade, that the synapses dissolve, that the electrical patterns cease, and that the specific configuration which was a person, the information that constituted their inner life, is lost. The question of whether that information is genuinely destroyed or merely transformed beyond recovery turns out to be more complicated than it appears. And the complication arrives from an unexpected direction. Consider what happens to the atoms in your body during your lifetime. Your skin is entirely renewed every 2 to 3 weeks. Your red blood cells are replaced every 4 months. Your skeleton is fully remodeled over a period of roughly 10 years. The atoms present in your body right now are largely not the atoms that were present 7 years ago. Almost every material constituent of you has been swapped out, replaced, cycled through, and returned to the world while you were getting on with other things. And yet you persisted. Your memories of childhood did not dissolve when the neurons that held them were rebuilt with different atoms. Your sense of being the same person you were a decade ago survived the complete turnover of your physical material. The pattern, The organization, the information, was maintained through the replacement of its substrate. Whatever makes you you, it is demonstrably not the atoms, it is the pattern. And the question of what happens to a pattern when its substrate is permanently destroyed is not simply a biological question. It is a question that reaches into the foundations of physics. In quantum mechanics, there is a principle called the no-hiding theorem. It was proved by Samuel Brownstein at the University of York and Aaron Paty, and its implications are worth sitting with carefully. The theorem states that quantum information cannot be destroyed. Not that it is difficult to destroy. Not that it tends to be conserved under most conditions. That it cannot be annihilated. The mathematics of quantum mechanics simply does not permit it. Quantum information can be scrambled. It can be dispersed across a system in ways that make its practical recovery impossible, ways that, for any realistic purpose, are as complete as destruction. But the distinction between scrambled and destroyed is, in the quantum mechanical framework, absolute. The information is always somewhere. It is always, in some sense, preserved. The black hole information paradox is the most dramatic arena in which this principle has been tested. For decades, Stephen Hawking's calculations suggested that information falling into a black hole is genuinely destroyed as the black hole slowly evaporates through what is now called Hawking radiation. He held this position through multiple confrontations with physicists who argued the other way. In 2004, at a conference in Dublin, he publicly conceded that he had been wrong. The information, he acknowledged, must be preserved, scrambled, transformed, returned to the universe in a form so complex as to be practically irrecoverable but not destroyed. Because quantum mechanics does not permit destruction, the universe, even at its most extreme, does not lose information. Now hold that principle alongside the OR framework discussed earlier, in which the information constituting conscious experience is quantum information, information encoded in the quantum states of microtubular proteins inside neurons. If that framework is correct, then the information that is you is subject to the same conservation law that governs every other quantum system. It cannot be annihilated. When the brain dies and the biological structure that housed it dissolves, that information is not destroyed. It is dispersed. It is scrambled beyond any practical hope of recovery. But it persists, in some form, in some configuration, in the quantum fabric of the universe. Hameroff has been explicit about what he believes this means. The quantum information in the microtubules does not disappear at death. It dissipates into the universe. Whether it reconstitutes, whether it ever reassembles into anything resembling the coherent pattern it once was, is a different question, and one that the current state of physics cannot answer. The gap between quantum information being conserved and personal subjective experience being preserved is enormous, and it would be dishonest to paper over it. The no-hiding theorem does not promise continuity of self. It does not promise that the felt, specific, first-person experience of being you persists, in any recognizable form, after the biological system that generated or hosted it is gone. What it promises is only that something of the quantum informational structure that constituted you cannot be entirely erased. Whether that something is enough is a question the mathematics does not resolve. But consider the structure of what has been assembled across this entire investigation. The dying brain surges with the most complex electrical activity it has recently produced, concentrated in the regions most associated with the integration of conscious experience. A molecule the brain manufactures naturally spikes at the moment of cardiac arrest, producing, when administered to the living, experiences structurally identical to what the dying report. People return from clinical death with verified knowledge of events that occurred while their brains were flatlined. People with devastated brains briefly become themselves again in the hours before death. Every civilization in human history has described the same architecture at the threshold of dying, independently, without contact, in different languages and different symbolic vocabularies. And quantum mechanics, at its most fundamental level, conserves the information that the brain encodes. None of these threads, taken individually, proves anything beyond what each study or theorem directly establishes. each can be accommodated by a sufficiently creative materialist account. The gamma surges are oxygen deprivation artifacts. The near-death experiences are the disinhibited brain's final narrative. The verified perceptions await a materialist explanation that has not yet been found. The terminal lucidity is the brief restoration of a dormant circuit. The cross-cultural convergence reflects a universal neurological event. The no-hiding theorem has nothing to say about subjective experience. Every one of these responses is serious. Every one of them may be correct. But taken together, as a pattern, as a convergence of independent lines of evidence pointing in the same direction from different disciplines using different methods, they constitute something that the intellectual honesty this investigation has tried to maintain requires acknowledging directly. The materialist account of death is not proven. It is the default assumption of a science that has not yet solved its most fundamental problem. And the anomalies, terminal lucidity, verified near-death perceptions, the hard problem itself, are not minor puzzles waiting for more data. They are structural challenges to the model's foundations. The possibility that something persists, that the pattern or the quantum information or the consciousness that was briefly organized into a specific person continues in some form beyond the dissolution of the biological substrate, is not ruled out by the evidence. It is, in several respects, suggested by it. What form that continuation might take, whether it resembles the self that the living knew, whether it constitutes experience in any sense we would recognize, these questions sit beyond the current reach of science. And they will probably sit there for some time. Here is what the convergence, the full convergence, across neuroscience and quantum physics and the world's oldest religious traditions, keeps insisting. Death is a process, not an instant. Every framework examined here, from the EEG data to the three-stage neurological model, to the dissolution of the elements in the Chikai Bardo, to the mythology of the crossing, all of them describe dying as something that unfolds over time, not something that happens in a moment. The corridor is longer than we assumed. The self ends. Every account, every framework agrees on this. The individual self, the bounded, ego-organized, narratively continuous entity that spends a lifetime being a specific someone, reaches a limit. Whether that limit is absolute or transitional is the contested question. But the ending of the self as it was is not contested. It is the one thing every tradition, scientific and religious and philosophical, agrees on. And something opens. The clear light, the tunnel, the panoramic life review, the dissolution into something larger, the quantum information dispersing into the universe. In framework after framework, what follows the ending of the self is not nothing. It is an opening into what precisely remains the deepest unresolved question in human thought. The moral weight of a life matters. This is perhaps the most consistent single message across everything examined here. The life review is not merely a replay, it is an evaluation. The weighing of the heart is not arbitrary. The karmic reckoning is not optional. The panoramic re-experience of everything you caused others to feel is not a punishment, it is a reckoning. Whether these descriptions reflect a genuinely moral structure built into the fabric of reality, or whether they reflect the dying brain's disinhibited access to the emotional memory of a lifetime, the message carried by all of them is the same. How you lived matters. Not after death, in the sense of determining a destination. Now, in the sense that the weight of your actions is accumulating in real time, and that at some point, whether at the threshold of a biological event or in the mathematics of a quantum system, it will be met. That is not a religious claim. It is the structure that appears when you look honestly at what the evidence, from every direction, keeps pointing toward. We are almost at the end of this investigation. One section remains: the honest accounting of what is known, what is inferred, and what cannot yet be said. And then the only conclusion that the evidence, taken in full, actually supports. Here is what we know. Not what we believe, not what we hope, not what any tradition or theory or framework requires us to accept. What the evidence, examined honestly and without presupposition, actually establishes. The dying brain is active. Gamma wave surges, organized, coherent, concentrated in the regions most associated with the integration of conscious experience, have been documented in both animals and humans at the moment of cardiac arrest and in the minutes that follow. This has been independently replicated. It is not a single anomalous recording. It is a pattern confirmed across multiple studies using different methodologies in different laboratories on different continents. The dying brain does not shut down. It does something. What that something represents, whether it constitutes conscious experience or is a neurological artifact of oxygen deprivation, is genuinely unresolved. But the activity is real, and it is documented. Near-death experiences are real phenomena. Structured, sequential, meaningful experiences are reported by a substantial proportion of cardiac arrest survivors across every study that has examined the question with rigor. These are not vague impressions or confused fragments. They are organized accounts with consistent features that recur across cultures, ages, and backgrounds, with a consistency that cannot be explained by prior belief or cultural expectation. A subset of these accounts includes verified perceptions of events that occurred during clinical death, accurate descriptions of specific actions and words that took place in the room while the patient had no measurable heartbeat and no brain activity sufficient to support the kind of processing that would generate them. These verified perceptions have not been explained by any current model of brain function. They have been documented and reported. The explanation remains open. Dimethyltryptamine is produced by the mammalian brain at neurologically meaningful concentrations. The enzymes required for its synthesis are co-expressed in neurons of the neocortex. Its concentrations spike during cardiac arrest in rats. The experiences produced by its exogenous administration maps structurally onto near-death experience reports, with a precision that extends across every major feature of both. Whether the human brain produces a psychoactive surge of this compound at the moment of death has not been confirmed. The animal data exists. The human extrapolation does not yet have direct evidence behind it. That distinction is real, and it matters. Terminal lucidity occurs. People with brains devastated by decades of neurodegeneration, brains that have lost the physical structures in which memory and personality are encoded, according to the standard model, recover full cognitive function in the hours before death. This happens with sufficient frequency that nearly 3/4 of palliative care professionals report witnessing it. It is now under large-scale prospective study with NIH funding. Its mechanism is not understood. Its occurrence is not in dispute. Consciousness remains the deepest unsolved problem in science. No theory currently available explains the mechanism by which physical processes in neural tissue give rise to subjective experience. The correlation between brain activity and conscious experience is beyond dispute. The mechanism underlying that correlation is not. Quantum effects have been demonstrated in biological systems operating at body temperature. The theory that consciousness arises from quantum processes in microtubules makes specific testable predictions, and the predictions made so far have not been refuted. The theory remains contested and unconfirmed. Every major civilization in human history has independently described a consistent architecture at the threshold of death, a journey, a guide, a moral evaluation, multiple possible destinations. These descriptions emerged without contact between the cultures that produced them. They converge on structural features that also appear in the clinical data collected by near-death experience researchers in the 21st century. The explanation for this convergence, neurological encoding of a universal dying event, or independent observation of a shared reality, has not been determined. That is what we know. Now here is what we do not know, stated with the same precision. We do not know whether the gamma surges in the dying brain represent conscious experience. We do not know whether verified near-death perceptions require a non-materialist explanation, or await a materialist one that has not yet been found. We do not know whether the human brain produces a psychoactive dimethyltryptamine surge sufficient to generate the near-death experience. We do not know the mechanism of terminal lucidity. We do not know whether OR correctly describes the substrate of consciousness. We do not know whether the no-hiding theorem's conservation of quantum information has any bearing on the survival of personal subjective experience. We do not know whether the cross-cultural convergence of afterlife descriptions reflects a universal neurological event or a universal territory. We do not know whether any aspect of personal consciousness survives the destruction of the biological brain. These are not gaps that will be filled next year. Some of them may not be filled within our lifetimes. They sit at the intersection of neuroscience, quantum physics, and philosophy, at precisely the point where each discipline reaches the limits of its current methods and looks across at the others for help. Sampanya, who has spent more time at the clinical boundary of death than almost anyone alive, and who has pursued these questions with more scientific rigor than any researcher before him, wrote that the research to date has neither proved nor disproved the reality or meaning of what patients experience at the threshold of death. He did not claim that near-death experiences prove the existence of an afterlife. He did not claim they are simply the misfiring of a dying brain. He reported what the data showed and acknowledged what it did not resolve. That restraint, the willingness to hold the genuine uncertainty without collapsing it in either direction, is the most intellectually honest position available. It is also, for many people, the most difficult one. Because the question of what actually happens after death is not an abstract question. It is the most personal question there is. It is the question that underlies every other question about how to live. What matters? Whether the kindness you show and the harm you cause have any weight beyond the immediate moment in which they occur. And here, at the end of this investigation, is what the full body of evidence, the neuroscience, the quantum physics, the psychedelic research, the ancient traditions, the documented anomalies that the standard model cannot comfortably accommodate, points toward when taken together. Death is longer than we thought. The process extends beyond the moment the clock is stopped, beyond the flat line on the monitor, potentially well into the period during which medicine has already declared the person gone. What happens in that extended window is not nothing. It is, by every measurement we have been able to make, the most intense and organized neural activity the brain has recently produced. The self that you are right now, the bounded, continuous, narratively organized experience of being a specific someone, reaches a limit at death. Every framework, without exception, agrees on this. The ego, the ordinary self, the sense of separation between you and everything else, it ends. What that ending gives way to is the contested question. Every tradition and every theory examined here describes something that follows, something larger, something less bounded, something that several traditions identify as more fundamental than the ordinary self that preceded it. Whether that description maps onto a physical reality or onto the biology of a dying brain is not yet known. The information that constitutes you is not, at the most fundamental physical level, subject to annihilation. Quantum information is conserved. Whether that conservation has any bearing on the continuity of your experience, whether the scrambled, dispersed quantum information that was you constitutes anything after the dissolution of your biology, is a question the no-hiding theorem establishes as open rather than closed. It does not answer it. It prevents the confident dismissal of it. And the moral weight of a life appears, in every framework that has looked carefully at the threshold of death, to matter. The panoramic life review is not a comfort. It is a reckoning. The weighing of the heart is not a formality. It is the full weight of how a life was actually lived, experienced without the filters and rationalizations that make ordinary self-assessment bearable. Whether this structure reflects something real about the architecture of the universe or something real about the architecture of the dying brain, the message it carries is the same either way. You are being built right now. Every interaction, every choice, every act of kindness, and every act of cruelty, every truth told, and every deception maintained, all of it is accumulating in the pattern that you are. And at some point, by some mechanism that the best minds in science have not yet fully mapped, that pattern will meet itself without the mediation of the ordinary self that generated it. What happens then is the question. Here is what is not in question. Your atoms were forged in dying stars. They were assembled, through billions of years of cosmic and biological process, into a temporary configuration capable of wondering about its own nature. You are the universe looking at itself through a particular set of eyes, asking what it is and what comes next, and whether anything of the pattern that is, you will persist when those eyes close. The fact that you are asking the question, that matter organized into neurons, organized into a self-organized into an awareness capable of wondering about death, is, by any honest accounting, the most improbable and extraordinary event in 13.8 billion years of cosmic history. The dying brain surges, the molecules rise, the pattern dissolves into something it cannot name. Whatever comes next, you were here. You wondered. And in the long history of a universe that spent most of its existence producing nothing capable of wonder at all, that is not nothing. That is everything.